the disk method. Suppose y equals f of x is continuous from point A to point B. We rotate the region under the function f between point A and point B about the x-axis and look at the volume of the solid of revolution. First, we look at the area before we rotate about the x-axis and draw one piece of the rectangle. After we rotate, that piece of the rectangle will form the disk. To find the volume of the solid of revolution, let's take a look at one piece of the disk. The volume of this disk is the sectional area multiplied by the thickness of the width. And the cross-sectional area is circle, so the area is pi r squared. Therefore, the volume of one disk is pi r squared times dx, or delta x as the thickness. If the thickness is delta x or dx, and the integral of integration is x equals a to x equals b, the volume of revolution v is the definite integral from point A to point B of pi times the radius as a function of the x squared dx, and pi r squared is the area, dx is the width. Another case, if the thickness is delta y or dy, that means the curve or the area under the curve rotates about the vertical axis, such as the y-axis. And the interval of integration is from y equals c to y equals d. The volume of revolution v is the definite integral from c to d of pi times the radius function as a function of the y squared times dy. Let's look at the example. The first one, use this method to find the volume of the solid generated when the region bounded by the following curve is revolved about the given axis. Part A, y equals square root x over the interval 0, 4 about the x-axis. With the graph provided, you could draw the graph of y equals square root x from 0 to 4, and this region rotate about the x-axis. Slicing technique tells you that one slice or one rectangle in the region here is perpendicular to the axis of revolution. That tells you the thickness is delta x or dx, where x is from 0 to 4. As you pretend like you move this slice or this piece to the left and to the right, starting from 0 to 4. So at this position x can be anywhere between 0 and 4. So delta x or dx is the thickness or the width. X from 0 to 4 is the interval of integration. And the radius r is the function in x or the height of the bar, which is y equals square root x. Next, we're going to set up the integration. So the volume by this method is the integral from 0 to 4, and the cross-sectional area, which is the area of the circle, or pi times the radius square, times the thickness or the width. Next, simplify the integrand. We have pi, take it out of the integral as a coefficient. So integral from 0 to 4 of x with respect to x. Find antiderivative of the x. We have x squared over 2. Evaluate from the lower limit 0 to upper limit 4. Replace the value of the upper limit 4 squared over 2 minus the value from the lower limit was 0 squared over 2. That will give us 8 pi as the result.